Welcome to Advanced Con Ed's 4-hour Oklahoma 2015 Plumbing Code Update, Part 1. Advanced Con Ed presents the significant changes to the 2015 International Plumbing Code with the State of Oklahoma Uniform Building Code Commission's amendments and modifications, Part 1. Introduction. Welcome, and thank you for selecting Advanced Con Ed to provide the continuing education you need to fulfill your licensing requirements. At Advanced Con Ed, we strive to present you with the most up-to-date codes and relevant safety information to keep you both technically current and safe on the job. This presentation provides you with the significant changes to, followed by a discussion of, the ICC's 2015 International Plumbing Code, presented in black text, as well as the Oklahoma Uniform Building Code Commission's amendments and modifications, presented in blue text. And now, Advanced Con Ed is proud to present the significant changes to the 2015 International Plumbing Code with the State of Oklahoma Uniform Building Code Commission's amendments and modifications, Part 1. Oklahoma Uniform Building Code Commission adopted code as amended and modified. The Oklahoma Uniform Building Code Commission, the OUBCC, hereby adopts the International Plumbing Code 2015 edition, IPC 2015, as amended and modified as the statewide minimum code for commercial plumbing construction in the state of Oklahoma. All chapters and provisions within chapters, including exceptions, of the IPC 2015 not specifically addressed within these rules as being modified, deleted, moved, or removed, are hereby adopted without modification as the statewide minimum code for commercial plumbing construction within the state of Oklahoma pursuant to 59 Oklahoma Statute, Section 1000.23. OUBCC adopted code as amended and modified, continued. None of the appendices of the IPC 2015 have been adopted by the OUBCC for inclusion in the statewide minimum code for commercial plumbing construction in the state of Oklahoma. However, other jurisdictions within the state of Oklahoma may adopt any or all said appendices in accordance with 59 Oklahoma Statute, Section 1000.29. The limited adoption of Chapter 1 is made in recognition of the authority and discretion possessed by jurisdictions to administer and enforce building codes. Exercising such authority and jurisdiction in a manner inconsistent with Chapter 1 must be supported by Oklahoma law. Code administration and enforcement jurisdictions shall not use the OUBCC's limited adoption of Chapter 1 to circumvent the remainder of the requirements established by the Oklahoma adopted IPC 2015, and the OUBCC will strongly oppose any such practice. Section 106.1.1 Annual Permit. 106.1.1 Annual Permit. An annual permit is a yearly permit which represents a group of individual permits for each alteration to an already approved electrical, gas, mechanical, or plumbing installation. The building official is authorized to issue an annual permit upon application thereof to any person, firm, or corporation regularly employing one or more qualified tradespersons in the building, structure, or on the premises owned or operated by the applicant for the permit. Section 106.1.2 Annual Permit Records. 106.1.2 Annual Permit Records. The person to whom an annual permit is issued shall keep a detailed record of alterations made under such annual permit. The building official shall have access to such detailed records of alterations at all times. At the completion of the entity's annual permit term, the applicant shall file such detailed records of alterations with the building official. Pursuant to the authority of 59 Oklahoma Statute, Section 1000.25, the building official shall collect fees for each individual permit which is part of the annual permit once the detailed records are submitted, and remit such fees to the OUBCC. Section 202. Definition: Plumbing fixture. Plumbing fixture: a receptacle or device that is connected to a water supply system or discharges to a drainage system, or both. Such receptacles or devices require a supply of water or discharge liquid waste or liquid-borne solid waste, or require a supply of water and discharge waste to a drainage system. Discussion. The previous definition of plumbing fixture was outdated and incomplete. The definition now includes receptacles and devices that do not necessarily require connection to a water supply. Waterless urinals and floor drains are now addressed in the revised definition. Section 202. Definition: Plumbing appliance. Plumbing appliance: water-connected or drain-connected devices intended to perform a specific function. These devices have their operation or control dependent on one or more energized components, such as motors, controls, or heating elements. Such devices are manually adjusted or controlled by the owner or operated, or are operated automatically through one or more of the following actions: a time cycle, a temperature range, a pressure range, a measured volume or weight. Discussion. The modified definition of plumbing appliance provides a better distinction between appliances and fixtures. The revised text updates and simplifies the definition, now recognizing these two classes as different. Examples of plumbing appliances include dishwashers, clothes washers, garbage disposals, water softeners, water purifiers, and water heaters. Section 202. Definition: Grease interceptor. Grease interceptor. Hydromechanical. Plumbing appurtenances that are installed in the sanitary drainage system to intercept free-floating fats, oils, and grease from wastewater discharge. Continuous separation is accomplished by air entrainment, buoyancy, and interior baffling. Gravity. Plumbing appurtenances of not less than 500 gallons capacity that are installed in the sanitary drainage system to intercept free-floating fats, oils, and grease from wastewater discharge. Separation is accomplished by gravity during a retention time of not less than 30 minutes. Section 202. Definition: Grease interceptor. Continued. Discussion. The provisions of Section 1003.3.4 addressing grease interceptors and automatic grease removal devices were never intended to apply to gravity grease interceptors. The new terminology now makes a clear distinction between the two types of grease interceptors, hydromechanical and gravity. The revision to the definition, along with changes made in section 1003.3.4, place the IPC in better alignment with product standards and industrial terminology. Both types of grease interceptors require diligent effort by restaurant facility managers and staff to ensure that they are regularly maintained and properly serviced. For a grease collection device to work correctly, it must be properly designed, installed, maintained, and serviced regularly. Section 202, Definition, Alternate On-Site Non-Potable Water. Alternate on-site non-potable water, non-potable water from other than public utilities, on-site surface sources, and subsurface natural freshwater sources. Examples of such water are gray water, on-site reclaimed water, collected rainwater, captured condensate, and rejected water from reverse osmosis systems. Discussion. A common problem in potable water saving designs that use non-potable water in buildings and on building sites is the understanding and naming of the different classes of non-potable water. The term reclaimed water, also known as recycled water, has been reserved for non-potable water that is delivered to the building site by municipal water delivery systems. The term on-site non-potable water is too encompassing, as this means both well water that has not been treated to be potable and gray water from showers and lavatories. The handling and treatment protocols and concerns for these two sources are quite different. Thus, municipally reclaimed water, on-site surface sources, and subsurface natural freshwater sources are excluded from this definition. All other on-site non-potable water is considered alternate on-site non-potable water. Section 202, Definition, Backflow Preventer. Backflow preventer, a backflow prevention assembly, a backflow prevention device, or other means or method to prevent backflow into the potable water supply. Discussion. Changes made in the 2012 IPC throughout many of the potable water backflow prevention sections slightly changed the nomenclature of backflow equipment. There are now three distinct classes of backflow equipment: assemblies, devices, and other means or methods. This class distinction clarifies that 1. An assembly is field testable, 2. A device is not testable in the field, and 3. A means or method is observable for its adequacy to protect the potable water supply from backflow. Section 202, Definition, Mechanical joint. Mechanical joint, a connection between pipes, fittings, or pipes and fittings that is not screwed, caulked, threaded, soldered, solvent cemented, brazed, welded, or heat fused. A joint in which compression is being applied along the center line of the pieces being joined. In some applications, the joint is part of a coupling, fitting, or adapter. Discussion. The process of heat fusing is primarily associated with the joining of certain types of plastic piping. The heat fusing process is different from the welding of pipe. Heat fusing can be performed by the butt method or the socket method. Heat-fused joints are not considered to be mechanical joints. Section 202. Definition: Toilet facility. Toilet facility: a room or space that contains not less than one water closet and one lavatory. Discussion: the common household name for a water closet is toilet. Most manufacturers of water closets call the product a toilet. Thus, the tendency by many readers of the code is to assume that a toilet facility is a room or space that has a toilet. This misunderstanding can create problems where the code requires separate male and female toilet facilities. One might incorrectly interpret this to mean that only separate male and female water closet compartments are required. The intent of the code is that separate male and female rooms or spaces that have not less than one water closet and one lavatory are required. Section 202. Definition: Waste receptor. Waste receptor: a floor sink, standpipe, hub drain, or floor drain that receives the discharge of one or more indirect waste pipes. Discussion: the common assumption has been that a floor sink and a hub drain are waste receptors. Standpipes and floor drains are rarely thought of as being waste receptors, but they are commonly installed for capturing flow from indirect waste pipes. The new definition includes all four items, and referencing waste receptors in the code text makes clear the restrictions for where these waste receptors can and cannot be located. Section 202. Definition: Building drain. Building drain: that part of the lowest piping of a drainage system that receives the discharge from soil, waste, and other drainage pipes inside, and that extends 5 feet in developed length of the pipe beyond the exterior walls of the building and conveys the drainage to the building sewer. Sections 202, 410.4. Drinking fountain, water cooler, and water dispenser definitions, substitution for drinking fountains. Drinking fountain: a plumbing fixture that is connected to the potable water distribution system and the drainage system. The fixture allows the user to obtain a drink directly from a stream of flowing water without the use of any accessories. Water dispenser: a plumbing fixture that is manually controlled by the user for the purpose of dispensing potable drinking water into a receptacle such as a cup, glass, or bottle. Such fixture is connected to the potable water distribution system of the premises. This definition also includes a freestanding apparatus for the same purpose that is not connected to the potable water distribution system and that is supplied with potable water from a container, bottle, or reservoir. Water cooler: a drinking fountain that incorporates a means of reducing the temperature of the water supplied to it from the potable water distribution system. 410.4. Substitution: where restaurants provide drinking water in a container free of charge, drinking fountains shall not be required in those restaurants. In other occupancies where drinking fountains are required, water dispensers shall be permitted to be substituted for not more than 50% of the required number of drinking fountains. Section 202, 410.4, Drinking Fountain, Water Cooler, and Water Dispenser Definitions. Substitution for drinking fountains. Continued. Discussion. In previous code editions, the term water cooler was interpreted as a bottled water dispenser that chills the water before dispensing. The code section on substitution for drinking fountains stated that water coolers and bottled water dispensers were the only sources of water that were allowed to substitute for up to 50% of the required number of drinking fountains. Thus, only bottled water dispensers could be used as substitutes for drinking fountains. Because the term water dispenser is now defined, the group of devices and apparatus that can be used for substitutions for required drinking fountains has been expanded. Section 202, Definition, Fats, Oils, and Grease Disposal System. Fats, oil, and grease disposal system, a plumbing appurtenance that reduces non-petroleum fog in effluent by separation or mass and volume reduction. Discussion. The definition describes a new type of grease interceptor that is being used to reduce the discharge of fog into public sanitary sewer systems and private sewage disposal systems. Hydromechanical and gravity-type grease interceptors collect fog so that it can be removed from the unit and disposed of in accordance to local regulations. These types of units can have some limitation in capturing low levels of fog. New types of fog disposal systems incorporate various processes such as thermal, chemical, electrical, and biological to internally dispose of some of the fog rather than simply capturing it in order to meet the stringent requirements of some wastewater utilities and state environmental agencies. The internal disposal process allows fog disposal systems to attain lower fog concentrations in the effluent. Sections 303.1 and 303.4, Material Identification and Third-Party Certification. 303.1, Identification. Each length of pipe and each pipe fitting, trap, fixture, material, and device utilized in a plumbing system shall bear the identification of the manufacturer and any markings required by the applicable referenced standards. 303.4, Third-Party Certification. All plumbing products and materials shall be listed by a third-party certification agency as complying with the referenced standards. Products and materials shall be identified in accordance with Section 303.1. Discussion. The modification to the identification provisions of Section 303.1 clarifies the intent of the code that products and materials shall bear the identification of the manufacturer as well as the identification requirements that are referenced by the applicable standard. As a result of the modifications made to Section 303.4, all plumbing products and materials must now be listed by a third-party certification agency. Table 303.4 was deleted as a result of the modifications made to Section 303.4. Section 305.3, Pipes through foundation walls. 305.3, Pipes through foundation walls. Any pipe that passes through a foundation wall shall be provided with a relieving arch, or pipe sleeve pipe shall be built into the foundation wall. The relieving arch or pipe sleeve shall conform to one of the materials and standards listed in Title 702.2 or as approved. The sleeve shall be 2 pipe sizes greater than the pipe passing through the wall. Section 305.4.1 Sewer Depth. 305.4.1 Sewer Depth. Building sewers that connect to private sewage disposal systems shall be a minimum of 12 inches or as approved by the authority having jurisdiction below finished grade at the point of septic tank connection. Building sewers shall be a minimum of 12 inches below grade. Section 308.9 Parallel Water Distribution Systems. 308.9 Parallel Water Distribution Systems. Piping bundles for manifold systems shall be supported in accordance with Table 308.5. Support at changes in direction shall be in accordance with the manufacturer's instructions. Where hot water piping is bundled with cold or hot water piping, each hot water pipe shall be insulated. Discussion. Hot water piping is now permitted to be bundled together with other cold or hot water piping. However, this installation method is only permitted where each hot water pipe is insulated. Manifold plumbing systems are control centers for hot and cold water that feed PEX supply lines to individual fixtures. Cold water pipes in the same bundle with uninsulated hot water pipes are known to absorb large amounts of heat. This code modification will lessen that costly heat transfer. Section 312.2 Drainage and Vent Water Test. 312.2 Drainage and Vent Water Test. A water test shall be applied to the drainage system either in its entirety or in sections. If applied to the entire system, all openings in the piping shall be tightly closed, except the highest opening, and the system shall be filled with water to the point of overflow. If the system is tested in sections, each opening shall be tightly plugged except the highest openings of the section under test, and each section shall be filled with water, but no section shall be tested with less than a 5-foot head of water. In testing successive sections, at least the upper 5 feet of the next preceding section shall be tested so that no joint or pipe in the building, except the uppermost 5 feet of the system, shall have been submitted to a test of less than a 5-foot head of water. This pressure shall be held for at least 15 minutes. The system shall then be tight at all points. Section 312.3 Drainage and Vent Air Test. 312.3 Drainage and Vent Air Test. Plastic piping shall not be tested using air. An air test shall be made by forcing air into the system until there is a uniform gauge pressure of 2.5 psi or sufficient to balance a 5-inch column of mercury. This test shall be held for a period of not less than 15 minutes. Any adjustments to the test pressure required because of changes in ambient temperatures or the seating of gaskets shall be made prior to the beginning of the test period. Section 312.6 Gravity Sewer Test. 312.6 Gravity Sewer Test. Where required, gravity sewer tests shall consist of plugging the end of the building sewer at the point of connection with the public sewer, filling the building sewer with water, testing with not less than a 5-foot head of water and maintaining such pressure for 15 minutes. Section 312.10.1 Inspections. 312.10.1 Inspections. Annual inspections shall be made of all backflow prevention assemblies and air gaps to determine whether they are operable in accordance with Chapter 1, Sections 104.3 and 105.3.2. Section 315.1 Sealing of annular spaces at penetrations. 315.1 Sealing of annular spaces. The annular space between the outside of a pipe and the inside of a pipe sleeve, or between the outside of a pipe and an opening in a building envelope wall, floor, or ceiling assembly penetrated by a pipe, shall be sealed in an approved manner with caulking material or closed with a gasketing system. The caulking material, foam sealant, or gasketing system shall be designed for the conditions at the penetration location and shall be compatible with the pipe, sleeve, and building materials in contact with the sealing materials. Annular spaces created by pipes penetrating fire-resistant rated assemblies or membranes of such assemblies shall be sealed or closed in accordance with Section 714 of the International Building Code. Section 315.1 Sealing of annular spaces at penetrations continued. Discussion. The modified text clarifies that only the ends of the annular space need to be sealed or closed. The term tightly caulked was removed as it was considered outdated language from an era of packing and pouring lead joints. The term pipe was added in reference to sleeves in order to clarify which sleeves are to be considered. It was considered important to add the requirements that sealing materials be compatible with all items they might come in contact with, and that the materials be suitable for the weather and temperature conditions of the application. There are several solvent-based caulking materials that affect plastic piping, and there are instances where a caulking material is inappropriate for outdoor conditions, resulting in rainwater damage to the building. An additional change was made to clarify and emphasize the importance of ensuring that where fire-resistant rated assemblies are being penetrated by pipes, specific materials and methods in accordance with the IBC must be used. Section 403.1 Determining minimum number of plumbing fixtures. 403.1 Minimum number of fixtures. Plumbing fixtures shall be provided in the minimum number as shown in Table 403.1 based upon the actual use of the building or space. Uses not shown in Table 403.1 shall be considered individually by the code official. The number of occupants shall be determined by the International Building Code. Discussion. In most cases, the IBC occupancy classifications will match the use of the building or space. The actual use of the building or space determines the plumbing fixture requirements. Section 403.3 Required Public Toilet Facilities Exception. 403.3 Required Public Toilet Facilities. Customers, patrons, and visitors shall be provided with public toilet facilities in structures and tenant spaces intended for public utilization. The number of plumbing fixtures located within the required toilet facilities shall be provided in accordance with Section 403 for all users. Employees shall be provided with toilet facilities in all occupancies. Employee toilet facilities shall be either separate or combined employee and public toilet facilities. Exceptions. Public toilet facilities shall not be required in 1. Open or enclosed parking garages where there are no parking attendants. 2. Structures and tenant spaces intended for quick transactions, including takeout, pickup, and drop-off, having a public access area less than or equal to 300 square feet. Discussion. Examples of small public access areas in building and tenant spaces that are used for quick transactions are automated teller machine lobbies, drop-off, pickup dry cleaners, and takeout-only restaurants. The intent is that the exception is for establishments where customers walk in, make a relatively fast transaction, and walk out. Section 403.3.2 Relationship of toilet rooms and food preparation areas. 403.3.1 Toilet room ingress and egress. Toilet rooms shall not open directly into a room used for the preparation of food for service to the public. Discussion. IBC Section 1210.5 has historically prohibited openings between a toilet room and any room or space where food is being prepared for the public, such as a commercial kitchen that serves a restaurant dining area. The rationale for toilet rooms not opening directly into rooms where food is prepared for the public is to keep the food preparation areas in a sanitary condition. Replicating the building code provision in the IPC will be helpful and increase efficiency for plumbing designers, installers, inspectors, and other IPC users. Section 403.3.6 Locking of toilet room doors. 403.3.6 Door locking. Where a toilet room is designed for multiple occupants, the egress door for the room shall not be lockable from the inside of the room. This section does not apply to family or assisted use toilet rooms. Discussion. The doors of multiple occupant toilet rooms must no longer be capable of being locked from inside of the room. Restricting the egress door in this way will reduce the possibility of inappropriate activities that are more likely to occur when an occupant can restrict entry into the toilet room. Such locking potential also restricts immediate egress from the toilet room when it may be necessary. Section 403.4.1 Directional signage for location of public toilet facilities. 403.4.1 Directional signage. Directional signage indicating the route to the required public toilet facilities shall be posted in a lobby, corridor, aisle, or similar space such that it can be readily seen from the main entrance to the building or tenant space. Discussion. The intent of this change is to require signage at the entrance of a building or tenant space so that persons entering such spaces are made aware of public toilet facilities and the general direction to those facilities. This also prevents the tenant from telling people that no public facilities are available. The requirement for a sign to be displayed at the entrance to the building or tenant space puts the tenant on notice that public access must be provided to public toilet facilities. Where the required signage is removed by the tenant, this section provides a basis for the code official to require that the tenant replace the sign. Section 403.5 Drinking Fountain Locations. 403.5 Required Drinking Fountains. Drinking fountains shall not be required to be located in individual tenant spaces, provided that public drinking fountains are located within a travel distance of 500 feet of the most remote location in the tenant space and not more than 1 story above or below the tenant space. Where the tenant space is in a covered or open mall, such distances shall not exceed 300 feet. Drinking fountains shall be located on an accessible route. Discussion. The travel distance restrictions of 500 feet maximum between a public drinking fountain and the most remote location in the tenant space, as well as the limitation requiring placement of the fountains not more than 1 story above or below the tenant space, is almost identical to the language used in section 403.3.2 for toilet facilities. The limiting distance of 300 feet in a covered mall building is the same distance required for toilet facilities. Section 405.3.1 Minimum water closet compartment size. 405.3.1 Water closets, urinals, lavatories, and bidet. A water closet, urinal, lavatory, or bidet shall not be set closer than 15 inches from its center to any side wall, partition, vanity, or other obstruction, or closer than 30 inches center to center between adjacent fixtures. There shall be at least a 21-inch clearance in front of the water closet, urinal, lavatory, or bidet to any wall, fixture, or door. Water closet compartments shall be not less than 30 inches in width and 60 inches in depth for floor-mounted water closets, and not less than 30 inches in width and 56 inches in depth for wall-hung water closets. Discussion. A wall-hung, non-accessible water closet compartment is now permitted to be 56 inches in depth, which is 4 inches shorter in length than required for a compartment containing a floor-mounted water closet. The IPC is now closer in agreement with the accessible water closet compartment depth requirement set forth in section 604.8.2 of ICC/ANSI A117.1 2009, where wall-hung water closets are provided in accessible water closet compartments. Section 405.4 Floor and Wall Drainage Connections. 405.4 Floor and Wall Drainage Connections. Connections between the drain and floor outlet plumbing fixtures shall be made with a floor flange or a waste connector and sealing gasket. The waste connector and sealing gasket joint shall comply with the joint tightness test of ASME A112.4.3 and shall be installed in accordance with the manufacturer's installation instructions. The flange shall be attached to the drain and anchored to the structure. Connections between the drain and wall-hung water closets shall be made with an approved extension nipple or horn adapter. The water closet shall be bolted to the hanger with corrosion-resistant bolts or screws. Joints shall be sealed with an approved elastomeric gasket, flange to fixture connection complying with ASME A112.4.3 or an approved setting compound. Section 405.4 Floor and Wall Drainage Connections Continued. Discussion. Historically, a flanged outlet connection for floor-mounted water closets has been the only acceptable method for making the connection between the drain and a floor outlet plumbing fixture. The recognition of a waste connector and sealing gasket allows for another acceptable type of water closet connection method that will make more water closet products available to designers and installers. The new allowance recognizes a commonly used international method of connection. ASME A112.4.3, a standard already referenced in the IPC and the International Residential Code, requires that the connection be leak tight to a pressure up to 10 psi. Such water closet designs are available in a wide range of rough-end dimensions. Section 405.8 Slip Joint Connections. 405.8 Slip Joint Connections. Slip joints shall be made with an approved elastomeric gasket and shall only be installed from fixture outlet to within 18 inches downstream of trap outlet seal. Fixtures with concealed slip joint connections shall be provided with an access panel or utility space at least 12 inches in its smallest dimension or other approved arrangement so as to provide access to the slip joint connections for inspection and repair. Section 406.1, 409.2 Backflow Protection for Clothes Washing and Dishwashing Machines. 406.1 Water Connection. The water supply to an automatic clothes washer shall be protected against backflow by an air gap that is integral with the machine, or a backflow preventer shall be installed in accordance with Section 608. Air gaps shall comply with ASME A112.1.3 or A112.1.2. 409.2 Water Connection. The water supply to a dishwashing machine shall be protected against backflow by an air gap that is integral with the machine, or a backflow preventer shall be installed in accordance with Section 608. Air gaps shall comply with ASME A112.1.3 or A112.1.2. Section 406.1, 409.2 Backflow Protection for Clothes Washing and Dishwashing Machines Continued. Discussion. The requirement for these machines to have an integral air gap or an external backflow preventer in the connections required that the inspector had to be able to inspect the internal air gap just as he would observe an air gap between a sink faucet outlet and the flood level rim of a fixture. Because disassembly or removal of the machine would be required for the official to perform this inspection, the requirement for an air gap is not easily enforceable. This modification adds the standards designation with which air gaps must comply, so that the enforcement can be accomplished by the inspector identifying those standard numbers either on the machines or in the literature for the machines. Section 407.2 Bathtub Waste Outlets and Overflows. 407.2 Bathtub Waste Outlets and Overflows. Bathtub shall be equipped with a waste outlet and an overflow outlet. The outlets shall be connected to the waste tubing or piping not less than 1.5 inches in diameter. The waste outlet shall be equipped with a watertight stopper. Discussion. Even though most bathtubs are installed with overflow, the code text has not previously been clear as to whether or not an overflow was required. New language specifically states that bathtubs must be provided with an overflow outlet. Overflows for bathtubs are a safeguard to prevent flooding and are now required to be installed in addition to the waste outlet. The insertion of the term watertight regarding the required waste outlet stopper clarifies that the purpose of the stopper is to allow the tub to be filled with water and hold the water in place. Section 410 Minimum number of required drinking fountains. 410.1 Approval. Drinking fountains shall conform to ASME A 112.19.1 / CSA B 45.2 or ASME A 112.19.2 / CSA B 45.1, and water coolers shall conform to ARI 1010. Drinking fountains and water coolers shall conform to NSF 61, Section 9. 410.2 Minimum number. Not fewer than 2 drinking fountains shall be provided. 1 drinking fountain shall comply with the requirements for people who use a wheelchair, and 1 drinking fountain shall comply with the requirements for standing persons. Exception. A single drinking fountain that complies with the requirements for people who use a wheelchair and standing persons shall be permitted to be substituted for 2 separate drinking fountains. 410.3 Substitutions. Where restaurants provide drinking water in a container free of charge, drinking fountains shall not be required in those restaurants. In other occupancies, where drinking fountains are required, water coolers or bottled water dispensers shall be permitted to be substituted for not more than 50% of the required number of drinking fountains. Section 410 Minimum number of required drinking fountains. Continued. Discussion. Although the minimum required number of drinking fountains for each type of occupancy has historically been addressed in the IPC, the IBC criteria have now been brought into the IPC to give it more clarity and to provide consistency within the IBC. No fewer than 2 drinking fountains shall be provided. The drinking fountains need not be in the same location in the facility, and a single fixture that accommodates both seated and standing persons is allowed. Restaurants are exempted from the requirements of drinking fountains, provided water service is available to customers in a container free of charge. Those restaurants that only provide water at a cost to the customer must have complying drinking fountains. Section 413.1 Food Waste Disposer Approval. 413.1 Approval. Domestic food waste disposers shall conform to ASSE 1008 and shall be listed and labeled in accordance with UL 430. Food waste disposers shall not increase the drainage fixture unit load on the sanitary drainage system. Discussion. The term grinder is not widely accepted in the food waste disposal and manufacturing industry. Grinder could imply the appliance merely changes solid food, such as meat, to ground up meat, such as hamburger meat. However, these appliances are designed to liquefy food so that when the food enters the sanitary drainage system, the discharge flows along the piping in a similar manner as water. Solids do not drop out of the flow to create flow blockage problems. Thus, these appliances effectively dispose of the food by turning the food into a liquid flow stream. The requirement for listing and labeling to a standard ensures that all necessary precautions have been taken by the manufacturer of the food waste disposers to protect users of these appliances from electrical hazards. Section 417.4.1 Walls and floors in bathtub and shower areas. 417.4.1 Wall area. Bathtub floors, shower floors, wall areas above built-in tubs that have installed shower heads, and walls in shower compartments shall be constructed of smooth, corrosion-resistant, and non-absorbent waterproof materials. Wall materials shall extend to a height of not less than 6 feet above the room floor level and not less than 70 inches above the drain of the tub or shower. Such walls shall form a watertight joint with each other and with either the tub or shower floor. Discussion. This section has been modified to clarify the requirements for where waterproof and corrosion-resistant materials are required for bathtubs and showers. The changes reinforce the underlying principles of making sure that the operation of the fixture does not cause water damage to the structure or present insanitary conditions for the user. This section is now identical to the same requirements in the International Residential Code. Section 417.5.2.6 Shower Pan Liner Materials. 417.5.2.6 Liquid type, trowel applied, load bearing, bonded waterproof materials. Liquid type, trowel applied, load bearing, bonded waterproof materials shall meet the requirements of ANSI A118.10 and shall be applied in accordance with the manufacturer's installation instructions. Discussion. Another acceptable form of waterproofing has been recognized for the on-site construction of shower floors. The membrane that is applied is a thin, load-bearing, waterproofing design specifically for the special requirements of ceramic tile, stone, and brick installations. A self-curing liquid rubber polymer and a reinforcing fabric are quickly applied to form a flexible, seamless, waterproofing membrane that bonds to a wide variety of substrates. The membrane must be applied in accordance with the manufacturer's installation instructions. Section 420.1 Water Closet Approval. 420.1 Approval. Water closets shall conform to the water consumption requirements of Section 604.4 and shall conform to ANSI Z 124.4, ASME A 112.19.2, CSA B 45.1, ASME A 112.19.3, CSA B 45.4, or CSA B 45.5. Water closets shall conform to the hydraulic performance requirements of ASME A 112.19.2, CSA B 45.1. Water closet tanks shall conform to ANSI Z 124.4, ASME A 112.19.2, CSA B 45.1. ASME A 112.19.3, CSA B 45.4, or CSA B 45.5. Electro-hydraulic water closets shall comply with ASME A 112.19.2, CSA B 45.1. Water closets equipped with a dual flushing device shall comply with ASME A 112.19.14. Discussion. Dual flush water closets offering a flushing mechanism that allows the user to choose between a standard flush volume equal to or less than the federal and code mandated maximum flush volume of 1.6 gallons per flush and a lower flush volume. Lower flush volumes can be used for flushing bowl contents that do not have solids except for toilet paper, and the standard flush volume is used for flushing bowl contents having solids. The standard covering dual flush water closets has been added to the IPC so that designers, installers, and code officials will be assured that these products will work as intended. Section 421.1 Whirlpool Tub Approval. 421.1 Approval. Whirlpool bathtubs shall comply with ASME A 112.19.7, CSA B 45.10, and shall be listed and labeled in accordance with UL 1795. Discussion. Any electrical appliance connected to a system that conveys water or liquid waste has the potential to misdirect electrical current to appliance housings and onto other conductive paths that could come in contact with humans. The requirement for listing and labeling Whirlpool tubs to a standard ensures that all necessary precautions have been taken by the manufacturer to protect users of these appliances from hazards. Section 423.3 Foot baths, pedicure baths, and head shampoo sinks. 423.3 foot baths, pedicure baths, and head shampoo sinks. The water supply to specialty plumbing fixtures, such as pedicure chairs having an integral foot bath tub, foot baths, and head shampoo sinks, shall be limited to a maximum temperature of 120 degrees Fahrenheit by a water temperature limiting device that conforms to ASSE 1070 or CSA B125.3. Discussion. Water heaters in establishments that include pedicure chairs with integral foot bath tubs, foot baths, and head shampoo sinks are often overtaxed during periods of high usage. Because clients' feet or heads could be inadvertently exposed to high water temperatures greater than 120 degrees Fahrenheit that could cause skin burns, temperature limiting devices are required on the water supply to these specialty plumbing fixtures to prevent such exposures. Section 424.8 Deck-mounted bath shower transfer valves. 424.8 Transfer valves. Deck-mounted bath or shower transfer valves containing an integral atmospheric vacuum breaker shall conform to the requirements of ASME A112.18.1 or CSA B125.1. Discussion. The requirements of ASME A112.18.7 are now covered in the harmonized standard ASME A112.18.1 or CSA B125.1. ASME will no longer publish or update the ASME A112.18.7 standard. The harmonized standard has greater coverage for materials and testing of the product. Faucet manufacturers are already familiar with the harmonized standard for their other faucet products. Section 424.9 Water Closet Personal Hygiene Devices. 424.9 Water Closet Personal Hygiene Devices. Personal hygiene devices integral to water closets or water closet seats shall conform to the requirements of ASME A112.4.2. Discussion. The American Society of Mechanical Engineers, ASME, Consensus Standard for Water Closet Personal Hygiene Devices, A112.4.2, is now listed in the IPC in order to help regulate these devices. This standard establishes general and performance requirements, test methods, and marking requirements for bidet sprays and other optional features as applied to water closets seats, and other retrofit devices. The application of the provisions within the standard will ensure protection of plumbing systems from backflow and protect public safety by limiting the temperature of the water dispensed. Chapter 5 Water Heaters. Chapter 5 Water Heaters. Revoked. Section 601.5 Rehabilitation of Piping Systems by Internal Lining. 601.5 Rehabilitation of Piping Systems. Where pressure piping systems are rehabilitated using an epoxy lining system, such lining system shall comply with ASTM F2831. Discussion. Metallic water service piping and water distribution piping can internally corrode, resulting in leaks. Replacing piping is often a very expensive option because the process of getting to the piping, the extended labor time to replace the piping in confined areas, the process of repairing finished building materials that were removed, and the time that the building or tenant space cannot be used during the replacement. Epoxy internal lining systems can be used to repair leaking piping without removal of the piping. Although some building materials might have to be removed for performing the lining work, the amount is often just a fraction of the materials removed to replace the piping. For potable water service applications, the standard requires that the materials comply with NSF 14 and NSF 61. The standard requires pressure testing of the lined piping. Section 605, Polyethylene of Raised Temperature PERT Plastic Tubing. Table 308.5, Hanger Spacing. Piping material, polyethylene of raised temperature. Maximum horizontal spacing, in feet, 2.67, or 32 inches. Maximum vertical spacing in feet, 10. Table 605.3, Water Service Pipe. Material, polyethylene of raised temperature plastic tubing. Standard, ASTM F2769. Section 605, Polyethylene of raised temperature plastic tubing. Table 605.4, Water Distribution Pipe. Material, polyethylene of raised temperature plastic tubing. Standard, ASTM F2769. Table 605.5, Pipe Fittings. Material, fittings for polyethylene of raised temperature plastic tubing. Standard, ASSE 1061, ASTM F877, ASTM F1807, ASTM F2080, ASTM F2098, ASTM F2159, ASTM F2434, ASTM F2735, CSA B137.5. Fittings for cross-linked polyethylene plastic tubing. Standard, ASSE 1061, ASTM F8077, ASTM F1807, ASTM F1960, ASTM F2080, ASTM F2003, ASTM F2159, ASTM F2434, ASTM F2735, CSA B137.5. Section 605, Polyethylene of raised temperature plastic tubing continued. 605.25, Polyethylene of raised temperature plastic. Joints between polyethylene of raised temperature plastic tubing and fittings shall be in accordance with Section 605.25.1 and Section 605.25.2. 605.25.1, Flared Joints. Flared pipe ends shall be made by a tool designed for that operation. 605.25.2, Mechanical Joints. Mechanical joints shall be installed in accordance with the manufacturer's instructions. Fittings for polyethylene of raised temperature plastic tubing shall comply with the applicable standards listed in Table 605.5 and shall be installed in accordance with the manufacturer's Installation instructions. Polyethylenes of raised temperature plastic tubing shall be factory marked with the applicable standards for the fittings that the manufacturer of the tubing specifies for use with the tubing. Section 605, Polyethylene of raised temperature plastic tubing, continued. Chapter 14, ASTM, F2735-09, Standard Specifications for SDR9 Cross-Link Polyethylene and Raised Temperature Tubing, F2769.09, Polyethylene of Raised Temperature Plastic Hot and Cold Water Tubing in Distribution Systems. Discussion. Provisions are now included in the IPC to address the use of polyethylene of raised temperature plastic hot and cold water tubing in distribution systems in water service and water distribution. Included in the introduction of PERT systems is a new standard, ASTM F2769, addressing its permitted use. The recognition of PERT materials and systems has resulted in additions to several tables within the code. Provisions addressing joints for PERT tubing have also been added, as well as a reference to new fitting standards, ASTM F2735. The pipe support table has also been amended to provide maximum support spacing requirements for PERT pipe. Section 605.2.1, Lead content of components conveying drinking water. 605.2.1, Lead content of drinking water pipe and fittings. Pipe fittings, joints, valves, faucets, and fixture fittings utilized to supply water for drinking or cooking purposes shall comply with NSF 372 and shall have a weighted average lead content of 0.25% or less. Section 605.2.1, Lead content of components conveying drinking water, continued. Discussion. If federal law went into effect on January 4th, 2014, requiring that pipe, fittings, joints, valves, and faucets that are used to supply potable water have not more than a 0.25% lead content, the federal law prohibits non-complying products from being introduced into commerce or installed. Any non-compliant stock that is new, old, or refurbished cannot be sold or installed after January 4, 2014. Existing installed products are not affected by this law. Products that are installed as part of a renovation must comply with the law. Some manufacturers might make both low lead compliant products and products that are intended to be used in non-potable water systems that do not require low lead compliant products. Contractors will need to be aware of the difference to avoid using the wrong product. With the increase in global access to plumbing products, contractors will need to be careful about the products that are being installed to ensure that federal law is not violated. Table 605.3, Polyethylene Water Service Pipe. Table 605.3, Water Service Pipe. Material, polyethylene plastic pipe, standard ASTM D2239, ASTM D3035, AWWA C901, CSA B137.1. Material, polyethylene plastic tubing. Standard ASTM D 2737, AWWA C901, CSA B137.1. Chapter 14 AWWA C901-08 Polyethylene Pressure Pipe and Tubing 1/2 inch through 3 inch for water service. Table 605.3 Polyethylene Water Service Pipe continued. Discussion. AWWA C901 describes polyethylene pressure pipe and tubing for use primarily as service lines in the construction of underground water distribution systems for use in potable water, reclaimed water, and wastewater service. AWWA C901 is the AWWA standard for PE pressure pipe, tubing, and fittings 1/2 through 3 inches for water. This standard is primarily for PE water service piping. AWWA C901 can be summarized as follows. Compounds 2306, 2406, 3406, 3408. Size range 1/2 inch through 3 inch. Diameter ID base, OD base, tubing. Pressure classes 80, 100, 125, 160, and 200 psi. Dimension ratio 9, 11, 14.3, 17, and 21. The AWWA C901 provides a wide selection of compounds and pressure classes. The safety factor is 2, and there is no routine test for each piece of pipe. Table 605.3 PEX water service pipe continued. Discussion. The added reference standard AWWA C904 addresses cross-linked polyethylene pressure pipe for use primarily as service lines in the construction of underground water distribution systems. This standard describes pipe and tubing made with a material designation code of PEX 1006 as established in ASTM F876 Specification for Cross-Linked Polyethylene PEX Tubing. AWWA C904 describes pipe in sizes 1/2 inch through 3 inches with a standard dimension ratio of 9, SDR9, and pressure class of 160 psi. Tables 605.3 and 605.4. Section 605.16 CPVC, AL, CPVC, Water Service and Water Distribution Piping. Table 605.3 Water Service Piping. Material: chlorinated polyvinyl chloride, aluminum chlorinated polyvinyl chloride, CPVC, AL, CPVC. Standard ASTM F2855. Table 605.4 Water Distribution Pipe. Material: chlorinated polyvinyl chloride, aluminum chlorinated polyvinyl chloride, CPVC, AL, CPVC. Standard ASTM F2855. Tables 605.3 and 605.4. Section 605.16 CPVC, AL, CPVC, water service and water distribution piping, continued. Discussion. Pollinated polyvinyl chloride pipe and tubing has been in the code for many editions. CPVC pipe is a homogeneous material all through the pipe wall. CPVC pipe and tubing is supplied in straight lengths and turns are made with fittings. CPVC aluminum CPVC tubing has a composite wall made up of an inner and outer CPVC layer with an aluminum core. The CPVC outer and inner layers are adhesive bonded to the aluminum core. The product standard is only for 1/2, 3/4, and 1 inch copper tube size. Dimensionally, the product has the same inner and outer diameters as CPVC tubing. CPVC, AL CPVC is installed with the same fittings used for CPVC tubing. The advantage of this product over CPVC tubing is that it is bendable either by hand or by standard copper tubing bending tools. The minimum bending radius is 6 times the pipe outside diameter. Sections 605.14.3, 605.14.5, 605.18.3, 605.22.2, 605.23.3, and Table 605.5. Groove and shouldered mechanical joints and press connect fittings. 605.14.5 Press connect joints. Press connect joints shall conform to one of the standards listed in Table 605.5. Press connect joints shall be installed in accordance with the manufacturer's instructions. Cut tube ends shall be reamed to the full inside diameter of the tube end. Joint surfaces shall be cleaned. The tube shall be fully inserted into the press connect fitting. Press connect joints shall be pressed with a tool certified by the manufacturer. 605.18.3 Grooved and shouldered mechanical joints. Grooved and shouldered mechanical joints shall comply with ASTM F1476, shall be made with an approved elastomeric seal, and shall be installed in accordance with manufacturer's instructions. Such joints shall be exposed or concealed. Section 605.14.3, 605.14.5, 605.18.3, 605.22.2, 605.23.3, and Table 605.5. Groove and shouldered mechanical joints and press connect fittings, continued. Table 605.5 Pipe fittings. Copper or copper alloy fittings shall comply with standard ASME B16.15, ASME B16.18, ASME B16.22, ASME 16.26, ASME B16.51, ASSE 1061, ASTM F1476, ASTM F1548. Gray iron and ductile iron fittings shall comply with standard ASTM F1476, ASTM F1548, AWWA C 110 A to 1.10, AWWA C153 A 21.53. Stainless steel Type 304 or Type 304L fittings shall comply with standard ASTM A312, ASTM A778, ASTM F1476, ASTM F1548. Stainless steel Type 316 or 316L shall comply with standard ASTM A312, ASTM A778, ASTM F1476, ASTM F1548. Steel pipe shall comply with standard ASME B16.9, ASME B16.11, ASME B16.28, ASTM F1476, ASTM F1548. Sections 605.14.3, 605.14.5, 605.18.3, 605.22.2, 605.23.3, and Table 605.5. Groove and shouldered mechanical joints and press connect fittings continued. Discussion. Standard ASME B16.51 for press connect fittings for copper tubing and copper pipe has been added to the code to provide an additional option for joining and connecting. These fittings have an internal O-ring that provides the sealing. The metal fitting is crimped into the pipe or tube. Connecting copper tubing and pipe in this manner is useful, especially where water in the piping cannot be evacuated to allow soldering or brazing, or where torches cannot be used. Standards ASTM F1476 and ASTM F1548 for grooved and shouldered mechanical joints have been added to the code to provide another option for joining a variety of pipe materials. ASTM F1476 covers the performance requirements and qualification tests for these gasketed mechanical joints. ASTM F1548 covers the materials, testing, inspection, and marking of the fittings that are used in the performance and qualification tests of ASTM 1476. The advantages of this type of joint are 1. Minimizing field installation time. 2. Skills for field assembly are minimal. 3. Some angular adjustment is possible for both installation and after installation. And 4. Joints can be easily disassembled to make changes to the system. Section 605.7 and Table 605.7. Valve compliance to standards. 605.7. Valves. All valves shall be compatible with the type of piping material installed in the system. Valves intended to supply drinking water shall meet the requirements of NSF 61. Valves shall conform to one of the standards listed in Table 605.7 or shall be approved. Table 605.7. Valves. Material: chlorinated polyvinyl chloride. Standard ASME A112.4.14, ASME A112.18.1, CSA B125.1, ASTM F1970, CSA B125.3. Copper or copper alloy. ASME A112.4.14, ASME A112.18.1, CSA B125.1, ASME B16.34, CSA B125.3, MSS SP-67, MSS SP-80, MSS SP-110. Gray and ductile iron. AWWA C500, AWWA C504, AWWA C507, MSS SP-67, MSS SP-70, MSS SP-71, MSS SP-72, MSS SP-78. Cross-link polyethylene plastic. ASME A112.4.14, ASME A112.18.1, CSA B125.1, CSA B125.3, NSF 359. Polypropylene plastic. ASME A112.4.14, ASTM F2389. Polyvinyl chloride plastic. ASME A112.4.14, ASTM F1970. Section 605.7 and Table 605.7. Valve compliance to standards. Continued. Discussion. Previously, only ball valves, gate valves, butterfly valves, globe valves, and plug valves that supplied potable water were required to comply with NSF 61. Missing from this list were pressure-reducing valves, backflow prevention valves, check valves, and solenoid valves. Now, all types of valves that supply potable water must comply with NSF 61. This increased coverage ensures that contaminants tested for under NSF 61 are not being imparted to the drinking water supply for the building. Standards for numerous types of valves have been added to the code so that some control specifications for these products are available. Without reference standards being identified for these important components of the plumbing system, there hasn't been a mechanism available for someone to certify that these products actually do meet the standards that a manufacturer says the product complies. Section 303.4 requires third-party certification of products and materials that are required to comply with standard referenced by the code. Section 607.1.1 Water Temperature Limiting Means. 607.1.1 Temperature Limiting Means. A thermostat control for a water heater shall not serve as the temperature limiting means for the purposes of complying with the requirements of this code for maximum allowable hot or tempered water delivery temperatures at fixtures. Discussion. Water heater thermostats cannot be relied upon to control the outlet hot water temperature of a water heater. Plumbing engineers and contractors have continued to recommend that hot water systems be designed with the intended storage temperatures for several reasons. A water heater is sized based on 140 degrees F. Higher temperatures reduce the threat of Legionella bacteria growth in the water heater tank. through the use of 140-degree water and mixing down to a safe delivery temperature around 120 degrees Fahrenheit to 125 degrees Fahrenheit, a consistent hot water delivery temperature is attained. A water heater thermostat is now prohibited from being used as a temperature limiting device where the code requires a limit for hot or tempered water. Section 606.7 Labeling of water distribution pipes in bundles. 606.7 Labeling of water distribution pipes in bundles. Where water distribution piping is bundled at installation, each pipe in the bundle shall be identified using stenciling or commercially available pipe labels. The identification shall indicate the pipe contents and the direction of flow in the pipe. The interval of the identification markings on the pipe shall not exceed 25 feet. There shall not be less than one identification label on each pipe in each room, space, or story. Discussion. Piping in bundles has been known to cause confusion as to the determination of the contents of the individual pipes. Tracing them back to the source is often difficult and time-consuming. Marking the bundled piping at designated intervals with the identification of the contents and direction of flow will help eliminate the possibility of a cross-connection occurring when repiping or renovating this type of plumbing system. Section 608.16.5 Connections to lawn irrigation systems. 608.16.5 Connections to lawn irrigation systems. The potable water supply to lawn irrigation systems shall be protected against backflow by an atmospheric type vacuum breaker, a pressure type vacuum breaker assembly, a spill resistant backflow preventer, or a reduced pressure principal backflow preventer. A valve shall not be installed downstream from an atmospheric vacuum breaker. Where chemicals are introduced to the system, the potable water supply shall be protected against backflow by a reduced pressure principal backflow preventer assembly. Conclusion. Thank you for selecting Advanced Con Ed to provide the continuing education credits you need to fulfill your licensing requirements. We hope you found this presentation helpful to make you a better tradesman. This presentation is available to you anytime in the event you need to reference it in the future. Again, thank you for reviewing Advanced Con Ed's presentation of the significant changes to the 2015 International Plumbing Code with the State of Oklahoma Uniform Building Code Commission's Amendments and Modifications, Part 1.